Komsomolsk-on-Amur. This city is now well known beyond the boundaries of this country. It is one of the main industrial centers of Russia with a population of almost 300,000 people. It is the location of one of the major Russian factories producing serial combat fighters. This factory has combined the latest scientific and technological achievements, covering the route from the slow-speed R6 through the super-maneuverable Su-35, providing jobs to thousands of qualified workers. Most of those people were sons and grandsons of those who started the glorious and sometimes thorny route. The route that still goes on. All these things are exhibits of the factory's museum. Great care is given to each and every detail of the past times, the times that make part of the big history, the history that started here on the bank of the great Amur River. The governmental decision to build an aircraft factory on the bank of the Amur River was taken in February 1932. In May of the same year, the first factory builders, Komsomol members, arrived on board the Captain Karpenko steamer at Zengi Nanai no-manned camp. An impassable taiga and an age-old swamp welcomed them at the place of the future factory. Their only tools were saws, pickaxes, and shovels, and the only mean of transport were horses. Yet construction of the factory, together with the city of youth, started at an enormous pace. The first dwelling houses, a club, and even a department store appeared soon, making the dream city become a reality. In autumn of 1932, the effort put into the factory construction was almost completely destroyed by a flood. The destruction was so heavy that the whole project had to be reconsidered. The construction site was decided to be moved 4.5 kilometers off the riverbank. Much time was needed to start it all over again. Over a year was spent on the preparation of the new construction, and despite of enormous hardships, the first stone was laid into the foundation of the mechanical shop on July 18, 1934, while within about a year from then, on July 15, 1935, the first of the workshops, the tool-making, was set in motion. Several months later, most of the manufacturing and servicing workshops were set up. Engineers, workers, and technicians from all over the country were coming to the factory. An entire course of the Voronezh Aircraft College graduates arrived at the factory. In 1936, the factory was commissioned as an effective aircraft manufacturing enterprise 1-6. The R6 reconnaissance aircraft became the first product manufactured at the Komsomolsk factory. This aircraft was already being made at other factories. Manufacturing of a serial aircraft was a good chance for the young factory to master its first product. The aircraft was assembled in the beginning of 1936. The factory workers celebrated their first labor victory. Basically, the R6 manufacturing program was completed by assembling 20 aircraft. By 1936, the R6 became outdated as a combat aircraft, but continued to be actively used for the economic purposes. In 1937, landing explorers in the Arctic, pilot Golovin performed the first flight over the North Pole on such aircraft. In the subsequent years, the aircraft was actively used for training pilots to transit to high-speed aircraft and then enjoyed wide use as a transport aircraft. During the war, military transportation with the help of R-6 were performed until 1944. The R-6 assembly was still on the way when the factory received a new assignment to start manufacturing a new DB-3 Illusion aircraft. The new project became a serious challenge for the factory. The DB-3 long-range bomber was a modern, well-armed aircraft. At that time, the aircraft design represented a piece of art. Most of the units and aggregates were technologically labor-consuming. The problems arising in this connection produced an obvious impact on the new product manufacturing rate. The mastery of the new aircraft faced great hardships. The Aircraft Ministry analyzed the developing situation and decided to send its specialists together with the Moscow factory's experts to provide long-term technical assistance. The newly arriving employees were appointed senior experts and heads of the factory's major workshops and departments. The efforts taken brought positive results. The first 10 DB-3 aircraft were produced in 1938. The same year, pilots Kokinaki and Brindinsky performed a direct Moscow-Spasdalny flight on an aircraft of the same type, while in 1939, pilots Kokinaki and Gordienko made a transatlantic flight to the United States on the airplane Moscow. The aircraft manufactured at the factory underwent continuous modernization. The new DB-3F already had more powerful engines, reinforced armor, and defensive weapons. The bomb load increased and a navigator cabin appeared in the nose of the fuselage. The improved version of the DB-3F was renamed into the Il-4 in 1940. But this did not end modernization of the aircraft. In the end of 1940, there appeared two modifications, the DB-3T torpedo bomber and the DB-3PT amphibious aircraft. The war unexpectedly rushed into the life of the factory just like into the life of the entire country. Over 3,000 factory workers went to the front at once. Those remaining in the rear forged victory in the workshops. It was their front, requiring no less determination than an open fight. On June 23, 1941, the next day after the Germany attack, the factory workers' general meeting decided to deem themselves drafted, assuming exceeding work of the front brigades, consisting of engineers and workers, became common practice from the first wartime months. Their task was to update the old equipment, and it was over-fulfilled. Besides updating machine tools, an absolutely new equipment was created. The front brigades were soon transformed into the front tools shops, and then into the front workshops. In spite of the tough production rate based on the daily aircraft issuance schedule, the factory technical units performed significant manufacturing management improvement by reducing the aggregates assembly cycle. The factory managed to increase aircraft production in the third quarter of 1941, bringing the Il-4 production rate at a level of 2 aircraft per day. Practically every second long-range bomber of those years was assembled in Komsomolsk. The significant factor of the wartime successful activity of the factory was its strive to increase the production rate. It was based not only on the improvement of technology and management, but also on the wide-range workers' initiative and implementation of the most advanced work methods. On July 18, 1942, the city was awarded the Order of Lenin for the exemplary performance in the sphere of aircraft manufacturing. Throughout the war, the factory supplied over 2,700 Il-4 aircraft to the front, which played a significant role in the combat activities. These aircraft made the basis for the long-range strategic aviation. As far back as in August 1941, the Il-4 aircraft made a bomb attack over Berlin. The same aircraft were successfully used in the north against the enemy's navy. The war ended, and the transition to the peacetime production was not a simple task for the factory. The large labor force was left with practically no workload after the intense wartime rhythm. Although wide-range consumer goods manufacturing was introduced at the factory by that time, it did not allow the workforce to show its creative potential. There was an urgent need for the production of a new aircraft. In the second half of 1945, citizens of Komsomolsk were assigned to master serial production of the Li-2 aircraft. The pilots described this airplane as the one you shouldn't keep from flying. The aircraft was designed under the most advanced methods of technology and manufacturing. A special workshop was built for the Li-2 in which the so-called loft pattern manufacturing method was mastered. By the way, this method is still utilized in the aircraft production. This aircraft manufacturing became a significant stage in the factory's history. The first Li-2 transport aircraft made in Komsomolsk took off in 1947. 2 years later, the passenger version of the same aircraft was made. The airplane was unique in its reliability and simplicity. For many years, it was successfully operating in the severe climate zones of this country. The total number of the aircraft of this type produced at the factory mounted to 350. A real technological breakthrough determining the future of the factory was the introduction and manufacturing of the MiG-15 fighter. The factory was assigned to start manufacturing the MiG-15 bis aircraft in 1949. The factory experts faced serious problems. Perfect aerodynamic forms, specific flight characteristics, and powerful armament caused the aircraft design being far from simple for its time. The task was even more complicated since the aircraft was produced simultaneously by several factories and it was necessary to arrange interchangeability of many units for the aircraft's successful operation. All this resulted in a new strategy of the factory equipment. This task required radical reconstruction of most of the factory workshops and creation of principally new works. Introduction of this jet aircraft and its subsequent modifications, the MiG-17 and the MiG-17F, gave the factory the necessary experience for the future production of the high-technology complexes. The time of the mastering and start of the serial production of these aircraft can easily be deemed as the factory's second birth. That was when the factory first entered the world aviation market and the MiG-17F were supplied to Egypt and Algeria. It was when the license for this aircraft production was transferred to the People's Republic of China. Successful results of the factory's jet fighters' serial production were reached due to the labor and talent of thousands of engineers, technicians, and workers. Throughout the MiG-15 and the MiG-17 production, a total of 830 MiG-15 bis and 2,000 MiG-17s were manufactured. (1956). Fresh, sparkling MiGs were still leaving the assembly line while the factory received a new assignment. Manufacturing of the Su-7, a new Sukhoi-designed supersonic perspective aircraft. This aircraft represented an outstanding achievement of the most progressive design ideas. Swift forms, an extended fuselage with a built-in air duct, a powerful engine, and a sophisticated scheme of the main chassis retraction into the wing provided aircraft with excellent flight characteristics. Although the Su-7 production entailed certain technological problems, it encouraged the factory workers for the wide range of creative improvements and achievement of a vast reconstruction of most of the factory's workshops and sections. The work on this aircraft required the factory to become an independent serial aircraft producer, providing for the entire technological scheme of turning a test sample into a serial combat fighter. The resulting aircraft appeared to be so successful that it served as a basis for numerous modifications. The factory was manufacturing several modifications of this aircraft throughout a term of 20 years, including the Su-7B combat fighter bomber, the Su-7BKL with a unique skiing chassis design, the Su-7U trainer with a dual cabin, and many others. fruitful technical ideas introduced in the Su-7 aircraft gave birth to long-lasting versions, one of which was the Su-17 variable geometry wing aircraft. The wing of this aircraft was like cut into two parts, one of which may turn with respect to the other, thus changing the angle. Such wing provided better takeoff and landing characteristics of the aircraft, adding to its combat maneuverability. From year to year, the military customers' requirements to the Su-17 combat qualities became more and more sophisticated. New modifications of the Su-17 appeared, including the Su-17M with improved onboard equipment, as well as the Su-17M2, the Su-17M3, and the Su-17M4. A series of the Su-20, Su-22, and the Su-22M was produced for our foreign customers. A total of 2,000 aircraft of different modifications were supplied to 18 countries of the world. Reliability and high combat efficiency of these aircraft always enjoyed the highest assessment from the foreign military experts.
Когда заканчивали школу летчиков-испытателей, нас опрашивали, куда бы вы хотели.
When we were finishing pilot school, we were asked where we would like to work. I wrote the following: the Sukhoi firm, Komsomolsk-on-Amur, and the Flight Test Institute as a third priority. But the leaders made a different decision, which I think was absolutely right. They sent me to Komsomolsk. Not all of the pilots have a chance to go through the manufacturing process and see how the aircraft is made. I was lucky to get into a highly qualified team in the Far East where people work not for money but conscientiously. I always remember those years spent at the factory in Komsomolsk as the most bright years of my life, when there was a lot of work to do, a great people to be with. Years were passing by, and the city on Amur was growing and developing together with the factory. Constantly expanding factory's activity required continuous inflow of new personnel. Like in the 30s, engineers, technicians, and workers were coming to Komsomolsk from all over the country. According to an old tradition, they gathered on the bank of the river right where the dream city was started to perform the waltz of their youth. In 1966, upon the order of the Ministry of the Aircraft Industry, the Factory 126 was renamed into the Far East Machinery Engineering Factory. The same year, without interrupting the main product manufacturing, the factory started to produce the Amethyst sea-based cruise missiles. The factory already had experience in manufacturing such a product when the P-6 missile complexes were introduced in the factory in the beginning of the 60s. Thus, the first portion of the Amethyst got into production already in 1967. Throughout its existence, the factory manufactured a variety of products, from consumer goods to missiles. By the way, the Amethyst cruise missiles have been manufactured for almost 20 years. However, the main business of the factory was the combat aircraft production for the Air Force of this country. In 1976, the Far East Machinery Engineering Factory was again renamed into the Komsomolsk Aircraft Factory, and a year after that it was named after Yuri Gagarin. Those years were signified by the introduction of a new supersonic fighter of the fourth generation. The new aircraft mastering started in 1976 when the first minor portion of the sample aircraft was produced, subject to further extensive tests.